Thank you. Welcome, everyone. Today I'll be talking about driving interactive experiences with WebRTC. I'm Joseph Monti. A little bit about myself. I'm a software engineer for about 15 years, and mostly in the telecom space. I'm using VoIP and SIP and audio, built large-scale web applications, heavily into data processing and machine learning. I've been using WebRTC for about 2 years on a few different applications. Most recently, I've been working on a new startup called FlexRTC. So interactivity and communications. WebRTC, as we've been seeing, is transforming the way that we communicate, but really context is critical to that conversation that you're having. It can give purpose to the conversation and allow you to see and work together in a way that allows you to interact with each other and see and work together. But in a lot of times, you would use screen sharing to be able to collaborate with each other. But in some cases, it's not quite enough to do everything that you want to be able to do, or at least to be able to work together most effectively. WebRTC does support screen sharing, but it does require a browser extension, but it's not interactive. It also does require some more bandwidth because you are transmitting your full video stream. And translating it to mobile is not really a great scenario. The mobile screen is about 80 to 90% smaller than on the desktop. And we've gone through a significant evolution in the way that we design mobile applications. That's significantly different than we do on the desktop. So trying to translate whether it's an application or a website directly between the desktop and mobile doesn't quite work. So what you want to be able to do is translate the data behind it, not just the full video of it. And remote desktop is another solution that you can use on top of this to allow people to collaborate together. But again, it's not supported. This isn't supported by WebRTC. Requires client-side software. There's some security issues. And again, it doesn't really work very well on mobile. Now on to some use cases. One of the biggest use cases is collaboration. One example of that is pair programming. Programming is moving to the cloud. Services like Cloud9 and coding allows you to program in a development environment in the cloud, and also lets you see what another person is doing and work on the same piece of code together. And as teams are getting more distributed, things like this are even more important. Another use case for collaboration is in education and training, allowing you to share documents, videos, graphics between each other, and giving real-time feedback. And this collaborative environment can be really important when you're having a conversation. Another use case is help and support systems. We've been starting with messaging platforms, or where you'll have an in-app messaging services like Intercom let the users communicate with support much more easily, but then taking that further to incorporating voice and video, and then even further from that, allowing data synchronization between the users and the agents or the support, so that the agents can not only see what the users are doing, but also perhaps control what they're doing and helping them filling out a form or interacting with them in some way, maybe directing them to certain products and things like that. Another really interesting use case that's been pretty popular recently is chatbots, virtual assistants, augmented intelligence. There's been amazing advancements in hardware and software using GPUs and deep learning. But to access these types of resources, you really need to use computing resources in the cloud. And WebRTC can provide you with a real-time data voice channel to those resources. Another one is gaming and virtual reality. WebRTC can really help there, not only providing you with the voice channel, but also a real-time data channel. As for synchronization and messaging and how you would implement something like this, when you're building a web or mobile application, those are dynamic by nature. You would You could hook into the events of your website, and then you could update your elements from the changes in your data model. But you can also use real-time asynchronous messaging to synchronize those events and data model changes across the network and between clients. There are a few real-time messaging solutions, and really what they're based on is WebSocket. WebSocket's a asynchronous messaging protocol built on top of HTTP. There's also frameworks like Socket.io that make this much easier to implement. But you can also get real-time messaging from your database layer. Things like RethinkDB and Firebase both provide real-time data stream from your database so that your application can react to changes that are made on the database to make it much easier to synchronize the data. There are still some challenges with this. It does require server-side implementations, and you need some way of getting the right information to the right users. So you can roll your own routing, keeping track of who's connected and who receives what, so that when your server receives a message from a client, it knows where and who to send it to, and that can be a bit of a challenge. The WebRTC Data Channel actually can help you quite a bit with this because it provides a peer-to-peer messaging over that same secure WebSocket or WebRTC connection. Here's a little code snippet. It's quite easy once you have a peer connection up and running. You can create a data channel within that, and then using that is very similar to what you would do with WebSockets. So you could register event handlers and then send your data and get some messages back. Network architecture-wise, you have peers, clients, and servers. There's mainly two ways you can build your architecture, or two main ways. You could have a client-server or the peer-to-peer where the clients are talking to other WebSockets are forced into a client-server model. But with a WebRTC, that blurs the lines of the peers, the clients, and the servers in that everyone is a peer, and you could build either of these architectures or more complicated ones, putting meshes on top of servers and things like that. So you could really be a little bit more creative in how you communicate your data and your voice and video between your clients. As far as comparing WebSockets and WebRTC Data Channel, I went through most of these. WebSocket and data channels are both real-time. The client-server and the peer-to-peer model we just talked about. The routing, the WebSocket, you would have to do something on your server side to be able to get your routing. But with the WebRTC Data Channel, the routing is only going to the peers that are connected for that user. Protocol-wise, WebSockets are based on an upgraded HTTP connection, which means that there's already a lot of application servers and things like that that already support WebSockets natively, so they are fairly easy to use that way. As far as the WebRTC Data Channel goes, it's based on, or it uses SRTP on top of TCP or UDP. And what's nice about the SRTP is that you can control how those messages are delivered and control things like the message ordering, how the retries and the timeouts are handled. So if you want to be able to control more about how those messages are passed reliably between the clients, you can do that a little bit more easily with the WebRTC Data Channel. In terms of latency, it's really based on the network path between your clients. So if client A needs to talk to client B through a server, then there's going to be some added latency there, so you can get a little bit better performance if you're going client to client, and that's where you can get much better video as well as audio and data improvements by going peer-to-peer. In terms of getting out of the sandbox, bringing a service or WebRTC or real-time platform into a production environment, there's a number of challenges there in maintaining a real-time infrastructure. Not just keeping the servers running, but keeping the latencies and network paths between them as low as possible and getting the best performance there so that you're not impacting the quality of service. You can scale your service through load balancing, and monitoring can be really important for optimizing and knowing when there are potential issues within your network. And of course, WebRTC When you're running a WebRTC service, stun and turn servers are really important, and I'm not going to get into it now, but those are going to be things that you'll have to worry about if you're putting up together a WebRTC infrastructure. In terms of load balancing WebSockets, you can't just use a standard load balancer because the load balancer needs to support the HTTP upgrade request. And there are load balancers that do support it, but you need to configure it specifically to be able to support that. Nginx and HA proxy both do that very well. I typically use Nginx. In terms of using AWS load balancers, up until recently, the AWS Elastic Load Balancer didn't support WebSockets. So if you wanted to do WebSockets in Amazon, you'd have to run your own server for that. But in August of this year, Amazon announced application layer load balancing so that you can configure an Elastic Load Balancer to support this application layer load balancing and enable its support for WebSockets. So you wouldn't need to run your own server if you're running something in Amazon. As far as WebRTC goes for load balancing, it's not so important for WebRTC gateway, unless you're using WebRTC gateways. Typically, what I would do is roll my own load balancing solution where I'd keep track of what servers are up and route robin your request to the available servers. In terms of monitoring, monitoring is somewhere where you'd want to gather client-side metrics, not just server-side metrics. And one of the really useful tools for that is the WebRTC Statistics API. And there's a bunch of information about how those network traffic is being used between the clients. And those types of statistics are really useful for optimizing your infrastructure, knowing what types of servers to deploy, the numbers of servers, and the locations of the servers. Lastly, FlexRTC is the startup that I'm working on right now. It's a platform for building real-time interactive user experiences, combining data, voice, and video. You can find us at flexrtc.com, or you can talk to me after. I'd be glad to talk to anyone about it. Thank you, everyone. And I think, do we have time for questions?
Yeah, we have a couple of minutes for questions. If you just please come up to the microphone if you have a question. I also say we were actually going to take a break now so we can grab more food, grab more drink. I'm sure Joseph would be happy to take your questions during the break. When we take one, then we'll stop for the break.
How much of your engineering time was spent on maintaining the turns, all the infrastructure, the turn servers and stun, compared to developing your client?
Those aren't as involved for specifically the stun and the turn. It depends on your type of application, but if you have like a complicated application service, that might be more involved that you had written, but those stun and turn aren't as involved as some of the other things. But it's still important to try to optimize, where your locations of those servers are, and that's probably what's most involved in trying to, optimize that.